Telescope, auto sequence start.
We are go for start.
25,
Booster hydraulic power units have started.
20,
Sound suppression water system has started.
15,
T-minus 13 seconds.
10,
T-minus 10, go for main engine start. We are go for main engine start. T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
You know the Hubble Space Telescope for some of the most stunning images ever taken of space. Glowing nebulas, newborn stars, galaxies from the edge of time itself. But here's what most people don't know. For its first 3 years in orbit, Hubble wasn't a marvel. It was one of NASA's biggest embarrassments. A telescope that cost over $1 billion, launched 300 miles above your head, and it couldn't even focus. This is the story of how Hubble went from a national joke to the most important scientific instrument of your lifetime. Let's go back to before Hubble even existed. Every star you've ever seen from the ground, you've seen through 60 miles of moving air. That air bends and warps starlight before it reaches your eyes. It's why stars twinkle, and it's why even the best, most expensive telescope on the ground can only ever see so clearly. You could build a telescope the size of a football stadium, and the atmosphere would still get in the way. For centuries, every astronomer on Earth was stuck with this problem. It didn't matter how much money you spent, or how big you built your mirror. The atmosphere was always going to be in the way. There was only one real fix: get above it completely. In 1946, a scientist named Lyman Spitzer wrote a paper laying out that exact idea. "Put a telescope in space," he said, "and you get a permanently clear view of the universe. No blur, no distortion, ever." It took more than 40 years, billions of dollars, and thousands of engineers to turn that idea into hardware. NASA named it after astronomer Edwin Hubble, the man who discovered that our universe is expanding. By the late 1980s, it was finally ready to fly. On April 24, 1990, the Space Shuttle Discovery lifted off carrying the most advanced telescope ever built. The next day, astronauts used the shuttle's robotic arm to lift Hubble out of the cargo bay and release it into its own orbit, 100 miles above Earth. For the first time in history, humanity had a giant, permanent observatory floating above the atmosphere. Scientists had waited decades for this moment. Reporters called it a new era for astronomy. NASA was about to show the world exactly what a telescope in space could do. Nobody on the ground had any idea what was about to go wrong. A few weeks after launch, the first real images came back down to Earth. They were blurry, not needs a small adjustment blurry. Every single image, every single star, was smudged and out of focus no matter what engineers tried. NASA launched an investigation. Engineers spent weeks combing through years of manufacturing records, trying to figure out how something built with this much precision could still be wrong. What they found was almost impossible to believe. Hubble's primary mirror, a piece of glass over 7 feet wide, polished more precisely than almost anything humans had ever made, had been ground into the wrong shape. The error was tiny. The outer edge of the mirror was off by about 2.2 micrometers. That's roughly 1/50th the width of a human hair. You couldn't see it. You couldn't feel it. But it was more than enough to ruin every image the most expensive telescope in history could take. Here's the cruel part. Nobody at NASA had been careless. The mirror had been polished to near perfection, perfectly matched to a testing device that was itself built wrong. Inside that device, one small lens sat just over a millimeter out of place. Every measurement taken from it was quietly, catastrophically wrong. Hubble's mirror wasn't a sloppy mistake. It was a flawless one. The fallout was brutal. Late-night hosts made Hubble the punchline of the year. Congress demanded answers. Newspapers called it one of the worst blunders in NASA's history. $1 billion telescope, and it needed glasses. There was just one problem. You can't send a repair truck 300 miles into space, or could you? Hubble couldn't come home, and its mirror couldn't be swapped out in orbit. So NASA engineers came up with a plan that sounded almost too simple to work. If the mirror was bending light the wrong way, build a set of corrective mirrors to bend it back. Essentially, glasses for a telescope. They called it COSTAR. In theory, elegant. In practice, it meant sending astronauts to attempt one of the hardest repair jobs in the history of spaceflight, 300 miles up, in a bulky pressurized suit with zero room for error. The crew trained for more than a year, rehearsing every single move underwater in a massive pool designed to mimic zero gravity. In December 1993, 7 astronauts launched aboard the Space Shuttle Endeavour. Over 5 back-to-back spacewalks, they worked to install CoStar and a new camera with the correction already built in. One dropped tool, one cross-threaded bolt, could have doomed the telescope for good. They didn't make that mistake. When the corrected images came back to Earth, the difference was staggering. Stars that had been smeared blobs of light snapped into sharp, perfect points of light. NASA didn't just fix Hubble. They saved it, and they saved their own reputation right along with it. Nobody knew it yet, but the real story hadn't even started. Once Hubble could finally see clearly, it didn't just work. It exploded with discovery, glowing clouds of gas where brand new stars are born. One image, nicknamed the Pillars of Creation, showed towering columns of dust lit from within by infant stars. It's still one of the most recognized photographs ever taken. Dying stars, blowing off rings and shells of colored light on their way out. Galaxies so far away and so strange, nobody on Earth had ever seen anything like them. Entire stars detonating in supernovas. Structures so enormous that comparing them to anything on Earth barely makes sense. It even watched a comet slam into Jupiter in real time in 1994, leaving impact scars in the clouds bigger than our entire planet. Hubble wasn't just doing science anymore. It was becoming something bigger, a cultural icon. Its images started showing up on posters, textbooks, and screensavers around the world. For the first time, ordinary people could look at the universe the way astronomers do. But the single image that changed the most wasn't a nebula, a dying star, or even a galaxy. It was almost nothing at all in December 1995. The head of the Hubble program made a call that a lot of scientists thought was reckless. Telescope time on Hubble is incredibly valuable. Astronomers wait months, sometimes years, for a few hours of it. So when the decision came down to point Hubble at a patch of sky that looked completely empty, no stars, no galaxies, nothing, and leave it sitting there for 10 straight days, some scientists were furious. To them, it looked like throwing away one of astronomy's most valuable resources on absolutely nothing. They aimed Hubble at a spot near the Big Dipper, a patch of sky roughly the size of a grain of sand held at arm's length, and they waited. Over 10 days, Hubble collected more than 300 separate exposures of that one empty spot. Then they stacked every image into one. What came back didn't look like nothing. It looked like almost 3,000 galaxies, packed into a sliver of sky small enough to hide behind a grain of sand. Spirals, smudges, galaxies from near the dawn of time, their light traveling toward Earth for over 10 billion years, just to be caught by this one telescope. The empty patch of sky wasn't empty. It was never empty. This is the moment that broke how astronomers, and eventually all of us, understood the universe. Every dark patch of sky above your head right now, every gap between the stars you can actually see, is packed with thousands of galaxies you simply can't see with your own eyes. There's no such thing as empty space. There's only space we haven't looked at closely enough yet. But when you look at anything, you're not seeing it as it is right now. You're seeing it as it was the moment its light left it. Look at the sun, and you're seeing it as it looked about 8 minutes ago. That's how long its light takes to reach your eyes. Now stretch that idea out. The farther away something is, the older the light you're seeing. Even the North Star, Polaris, the light reaching your eyes tonight left hundreds of years ago. And in space, farther away can mean billions of years in the past. When Hubble looks at one of those distant galaxies from the deep field, it isn't just looking far away. It's looking backward in time, to a version of the universe that existed before Earth, before our sun, before almost everything you know had formed. Hubble isn't just a camera. It's the closest thing humans have ever built to a time machine. Remember how Hubble got its name? Astronomer Edwin Hubble made one of the most important discoveries in the history of science. The universe isn't standing still. It's expanding in every direction, all the time. That single discovery changed how we understand where the universe came from, how old it is, and where it might be headed. For decades afterward, scientists argued over exactly how fast that expansion was happening. That number even has a name, the Hubble constant. It's not just trivia. That single number helps tell you how old the universe is and hints at where it's headed. Using the Hubble telescope, astronomers finally measured that number with incredible precision by watching a special kind of star flicker in galaxies millions of light years away. It was one of the main reasons Hubble was built in the first place, and it delivered. But here's the twist. When scientists measure the expansion rate one way, they get one answer. When they measure it a different way, using light left over from the early universe, they get a slightly different answer. Nobody has fully explained why yet. Astronomers call it the Hubble tension, and it might be pointing towards something about the universe we still don't understand. Sometimes the most exciting discoveries aren't answers. They're the questions we didn't even know to ask yet. Black holes are, in NASA's own words, invisible monsters. Their gravity is so extreme that not even light can escape, which creates an obvious problem. How do you photograph something you can't see? You don't. You look for what it's doing to everything around it. Hubble helped prove that almost every galaxy, including our own, has a supermassive black hole hiding at its center. Not by photographing the black hole itself, but by watching stars and gas whip around an invisible point in space, moving in ways only extreme, hidden gravity could explain. Over the years, it's helped astronomers track down hundreds of these hidden giants this way. Then, in 2023, Hubble found something nobody had ever seen before. Astronomers were scanning an old Hubble image when they noticed a strange, thin streak of light. At first, they figured it was a camera glitch. It wasn't. It was a supermassive black hole, roughly 20 million times the mass of the Sun, that had been violently flung out of its home galaxy, and was now rocketing through space so fast it could cross the entire distance between Earth and the Moon in about 14 minutes. Theorists had predicted galaxies could eject black holes like this for 50 years. Nobody had ever actually caught one in the act, until now. As it plowed through gas, it compressed that gas so hard it triggered the birth of brand new stars behind it, forming a glowing trail 200,000 light-years long, roughly twice the width of our entire galaxy. You'll never see a black hole with your own eyes. But thanks to Hubble, you now know exactly what one looks like when it's running for its life. Hubble was built to last 15 years. It launched before Google existed, before the iPhone, before most people owned a digital camera. Some of the scientists analyzing its data today weren't even born when it launched. And more than 3.5 decades later, it's still up there, right now, still taking pictures of your universe. It hasn't been easy. The space shuttle program that once carried astronauts up to repair Hubble has been retired for over a decade, which means there are no more house calls. When some of Hubble's gyroscopes, the parts that let it aim at targets, started failing, NASA couldn't just send a repair crew. Engineers got creative instead, switching Hubble over to run on a single gyroscope in 2024 to stretch its working life into the 2030s, and it's still delivering. In January 2026, astronomers used Hubble to help confirm something they'd suspected for years, that the massive, dying star Betelgeuse has a hidden companion star, one whose orbit was leaving a visible wake in Betelgeuse's outer atmosphere, finally solving a mystery around one of the most famous stars in the night sky. More than 3 decades after a nearly invisible mistake almost ended it before it began, Hubble is still finding things nobody has ever seen before. A telescope that was supposed to be NASA's proudest achievement almost became its biggest failure instead. What it became was something bigger. Proof that a mistake, even a billion-dollar one, doesn't have to be the end of the story. Hubble showed you nebulas where stars are born, and black holes tearing through galaxies as they flee. It showed you that empty sky is never really empty, and that when you look far enough into space, you're really looking back in time. It even helped rewrite the story of how big the universe is, and how old. None of that happened because Hubble launched perfectly. It happened because when it didn't, nobody gave up on it. Engineers went back, figured out exactly what went wrong, and fixed it, 300 miles from the nearest repair shop. Somewhere above your head, right now, Hubble is still up there, still looking, still finding things no human has ever seen before. If this made you see the night sky a little differently, hit subscribe.